So Kirchhoff's current law is very helpful for us because as we move now into other circuits, this is going to be important for our understanding here. The sum of the charge entering a junction should equal the sum of the charge exiting the junction. We've actually been assuming this for a while here. If we've got 0.93 amps flowing through here, and that 0.93 amps comes to a junction, that's going to split. In this case, it splits into 0.39 amps and 0.5454. Now, both of these are going to come back together, and then so as it exits here, it's going to have the same. It'll have 0.93 amps, as it comes into the junction and then as it leaves the junction. So if we take a look at this circuit here, let's say we have a 12-volt source. We have a resistor that's 10 ohms. This is the depiction of the way it'll look like in a for IV notation, kind of a box look in there for a resistor. We'll set up our starting point here. Basically, what we're going to be doing in this section is using Kirchoff's loop rules. And this is a really helpful technique, especially as we get into more than one voltage source. We'll really have to use this technique here. So we have our starting point, and let's say that the current is going around this way. We'll say that the current is flowing around this way. This is the positive terminal, and let's say that we want to set up our loop inside. So we're going to set up our loop inside going this way. What we're going to do is we're going to add up the voltages along the way. That's the first thing that we're going to do. So if we start from our starting point and we're following the purple here, we're going from the negative terminal to the positive terminal. And when we do that, we're going from the negative to positive. So we're going to add up 12 volts there, going from the negative to positive side. So we're going to count the voltages positive because we're going in that direction. So we have that, sum of the voltage plus 12. Next, we're going to go through a resistor. Now, as we go through this resistor, we're saying that the current is going this way and the loop is going this way. And because it's in the same direction as the loop, we're going to say that this resistor is using up some of this voltage, and so it'll therefore be negative. So we'll have negative 10, V from V equals IR from the Ohm's law, negative 10 times I being the current passing through. So Kirchhoff's loop rule states that the sum of the voltage will add up to be 0. Once you get back to your starting point, they should add up to be 0 because all that voltage river is going to be used up. And so therefore, the power delivered to the cell, is current times voltage. And then the EMF there times voltage. Power used is I squared R. And power equals power is used up in the resistor. We can cancel from both sides. And in this case here, we can figure out how much is used up there. For our case here, we have, the sum of the voltages is 0. We can bring the negative 10 to the other side. So there's going to be 1.2 amps of current passing through. Now, this is a very, very basic example starting out to see how this works. And if we did this, like we normally have, we know we've got a voltage source, we've got our resistor, we can figure out, what's going on. And this technique, we're going to just kind of build from that as we go. Let's go the other way. Let's say we know the current's going this way, but we're going to make our loop go the other way. And we can do that. We can choose the direction of our loops, and we'll do that. So first we encounter a resistor. Now, in this case, we're saying that the current is going around from in a clockwise manner, but our loop is going counterclockwise. And so if we go through a resistor in the opposite direction of current, which we are here, we're starting here, we're coming around, then we count the current times the resistance is positive. So we've got that. Now the next thing that we encounter is the cell. As we go through our loop, we're going to experience the positive terminal, then the negative terminal. And because we go from the positive terminal to the negative terminal, we're going to have a negative voltage. So negative 18. And so the rule is if your loop is in the opposite direction of the current, and the loop is in the opposite direction of the voltage source for going from a positive to negative terminal, that's negative. And you'll see that we'll get the same thing, 1.8 amps. with a 18 volt source. I think the last one actually had a different voltage of the source. We could have made this 12 as well, and we would have gotten 1.2. So yeah, so you can see how that works. So the rules so far, the sum of the voltage is 0. Voltage adds when going from a negative to positive terminal. Voltage subtracts when going through a resistor in the same direction of current. And then voltage subtracts when we're going from positive to negative side. And then voltage adds when we're going through resistor opposite the direction of the current. So you can think of it like we're getting voltage back. All right, so let's take a look at this situation. Let's say we have a 24 volt cell. We have a 40 ohm resistor and a 25 ohm resistor. We want to find the overall current using the techniques here. So let's go ahead and set up our loop. Let's assume that the loop is going around like this. And let's say that the current is coming around like this. And, we're assigning the direction of the current. It's pretty easy to do that right now. This is the positive terminal, this is the negative terminal. So we know that's happening. There's going to be a point, though, which we won't be exactly sure which way the current's going. And so we'll choose that. But for right now, we know that the current is going to be going this way from the positive terminal around. So, yeah, I'm going to have you try this one. You can pause the clip and give this a try. Go ahead and add up start at the starting point right here, and add up the voltages as you go, and then see if you can, determine the current using Kirchoff's loop rule so far. So go ahead and pause the clip and do that, and when you're ready to check, you can hit play to continue. All right, so the first thing that we encounter is our voltage source. We're going from the negative terminal to positive terminal, so positive 24 volts. Next, we encounter a resistor, and we have a certain amount of current times that resistance coming through. Next, we encounter the 25 ohm resistor, and again, our loop is in the same direction as the current, so negative 25 times the current. And when we solve for the current, we should get 0.37 amps. All right, so what if we did this in the opposite direction? I'm going to have you try this too. Go ahead and add up the voltages based on this. We'll keep the current, however, same direction, but we'll have the loop in the opposite direction. And so let's see if you can do that, and we'll see what we get here. So go ahead and pause the clip and try that. And when you're ready to check, you can hit play to continue. Okay. So the first thing that we counter is the 25 ohm resistor. Now our loop is in the opposite direction of current, so we're going to add this one up, positive 25 times the current. Then we get to the 40 ohm resistor. We multiply that by the current there. And then we go from the positive terminal to the negative terminal, so negative voltage, therefore with the cell. We add them up and we should get the same thing, 0.37 amps. So what I want you to do is go to FET, Circuit, Construction, Kit, DC only, and do this in Google search it. And what I'm gonna have you do is use a dual voltage source. So I would want you to set it up like this. You could have resistor on either side, and then you'd have voltage sources going against each other. If you notice here, the 12 volts and the 9 volts both are going against each other. And just see what happens. And this is where we're moving now, and this is why we needed to use Kirchoff's loop rules for those other ones where we could have used a different method, because now we're going to be incorporating multiple sources. So for this one, we're going to establish our starting point here. We'll start our loop going this way. We could have started the loop going the other way, and that would be fine. Now the trick in this one is, which way is the current actually going to go? This is the positive terminal here. This is the negative terminal. This is the positive terminal. This is the negative terminal. Yeah, they're actually going to be fighting each other, right? So in this one, we kind of know which one's going to win. We know that the 12 volts going to win. So current's probably going to move around this way. we'll go ahead and establish that. I don't know if I forgot to draw it. So current, we're assuming, is going this way. Now, if we would have set up the current the other way, that would have been okay, because what will happen is at the very, very end, our answers will come out as a negative, and that just lets us know that the current direction that we've chosen is backwards. So let's go ahead and set this up here. We're going to set up the same rules. I'll let you go ahead and finish this, where you get the voltage and the current or the resistance times the current for each of these, and solve for current. So go ahead and follow our same rules here and see if you can find the current. So pause the clip, and then when you're ready to check, you can hit play to continue. Okay. So assume the loop is in the same direction of current. That we're assuming that the current again is coming around like this. And so we have -4 times I. We're continuing to come around. Then we get to from the positive to the negative side. So therefore it's -9, going from the positive terminal to the negative terminal. And then we come finally to the last one where we say the current is going this way and the loop is going this way. And so -2I. And then we end up solving for it. We should get 0.5 amps as the current that goes through. And since it comes out as positive, we know that we went the right way. Let's say I actually sent the current, and I said the current's coming around this way. That would have been fine. Our final answer, and everything would have been backwards here. Our final answer would have come out as -5. That just means we got the direction wrong, and so the current's actually going the other way. So why don't you try this one, just so that we're all on the same page. Let's start here, and you can figure out the direction of the current on this one actually a little bit easier. And yeah, I'll go ahead and work through this, and then when you're ready to check, you can hit play to continue. Okay, so this is the negative terminal, this is the positive terminal, right? So, and then this is the negative, this is positive, so that's kind of easy. We know that the current's probably going to be going this way. Should be going this way, current going around. So first thing we encounter is the 25 ohms times -I, and then we get to the 15 ohms, negative terminal to positive 15. Then we get to the next one, -30 times I, and then +10, and we add them all up, and we get 0.4545 amps for our overall current. So this is what we had before. This is the loop rule summary. Now with more than one voltage source, if the current comes out as positive, then we know we got the current direction correct. But if it comes out as a negative, that means that we got the number right. It's just that the direction of the current is opposite of what we pictured. All right, so let's practice our loop here. I'm going to have you try it here. Let's start from the top left, make our loop come around, and we'll make the current come around this way so we're all on the same page. Yeah, we'll go ahead and practice this one. Pause the clip and give this a try, and then when you're ready to check, you can hit play to continue. All right, so we should get for the first one -5 times I, and then going from the negative to positive terminal, positive 3 volts. The current and the loop are in the same direction for the 19, so -19 times I. Same thing for the 3 ohms, so -3 times I. And then from the negative to positive terminal with the 18 volts, positive 18. We add them up, and we should get 0.78 amps.